Welcome back, everyone. We're diving deep again today. And this time, we're looking at the world of machining.
Okay.
Now, I know what you're thinking. Machining doesn't sound too thrilling, right?
Right.
But stick with me on this one. We're going to be looking at a document about some seriously impressive tools that are really shaking things up in the manufacturing world.
Okay.
We're talking about a whole new line of solid carbide Endmills.
Right.
With something called a Weldon shank. Now, I'm not going to lie, before I dug into this document, I had no idea what a Weldon shank even was.
Yeah, I get that.
Did you ever work with those?
Not super common, but they are getting more and more popular, especially for jobs where you need some serious muscle.
Really?
Yeah, you see a Weldon shank. It has these flat surfaces milled right into it,
I see.
and that lets you clamp it down really securely, prevents any spinning or slipping when it's working, gives you way more control as a machinist.
So it's all...
Especially at high speeds.
Stability.
Exactly, and precision, too.
Makes total sense. So we've got these Endmills with their super grip shanks, but there's more to it, right?
Oh, yeah.
This document goes on about them being designed for all sorts of operations.
Yeah.
From roughing to semi-finishing.
Yep.
And then there's the high-speed machining part.
Right.
Have you ever seen a machine work at those speeds?
Oh, yeah. It was pretty impressive.
It's mind-blowing. What are the big advantages there?
Well, for one, you can get things done a lot faster.
Faster production times, got it.
Tighter tolerances, too. Smoother finishes.
So it's not just about speed.
No, it's about precision, too. You can make some really intricate designs.
Interesting.
Stuff you couldn't even dream of before.
So we're talking about speed, accuracy, and intricate designs. But how do they pull it off? The document mentions a 7-flute design with different helix angles and variable pitch. I'm trying to picture that in my head.
It's like, imagine the flutes, those grooves along the cutting edge.
Okay. 7
of those, and they're not all at the same angle.
So that's the helix angle part.
Exactly. And the spacing between the cutting edges isn't even either.
The variable pitch?
Yep, and all that. It helps break up the chips you get while you're cutting.
Oh, that makes sense.
Especially with tougher materials, prevents those long, stringy chips.
I could see how that would be a problem.
Yeah, clogs everything up.
So the flutes are important, but then there's the size of the chip flute. The document calls it enlarged.
Yeah.
Which seems kind of weird, right? Wouldn't a bigger flute mean less space for cutting?
You'd think so, but remember all those chips flying around?
Oh, yeah, with high-speed machining.
Well, the bigger flute, it gives those chips more room to escape. Keeps them from piling up and messing up your cut.
Makes sense.
It's a balancing act. You need enough room to cut, but also enough room for those chips to get out of the way.
Speaking of balancing acts, this document dives into the material.
Oh, yeah.
A specific carbide grade, IC902, and then a titanium aluminum nitride PVD coating. Now, I gotta be honest, those sound pretty impressive, but I don't really know what they mean.
Well, IC902 is a type of carbide, specifically for machining hardened steel.
Nah, so it's tough stuff.
Really tough, can handle the heat and pressure.
What about that titanium aluminum nitride coating?
TLN PVD. That's pretty common, actually. But they're using a special process here.
Oh, I see.
Makes the coating super even and durable.
Makes it even tougher.
Yep. Less friction, more heat resistance, like giving it a suit of armor.
Wow. They really went all out. But there's one more thing. The H6 shank tolerance.
Right?
Now, I know tolerance is all about precision.
Absolutely.
Which is obviously crucial in machining. Can you break down what that H6 means?
Sure. So H6 means the dimensions of that shank are super precise. Really tight tolerance range.
So it fits perfectly in the holder.
Exactly. No wiggle room. No unwanted movement or vibration while it's cutting.
That makes sense.
It's all about maintaining that accuracy.
So to recap, we've got these super durable Endmills with a special shank for a rock-solid grip. They're designed for speed and precision. It's incredible to see how these innovations are changing the game in machining. Where do you think all of this is headed?
I think we're just getting started, honestly.
Really?
Yeah, with these tools, we can make even more complex parts with finer details than ever before. We could be making things that were impossible just a few years ago.
It's amazing how a tool like this can have such a big impact.
It really is.
Thanks for taking this deep dive with me.
Anytime.
For everyone listening, keep an eye on these advancements. They really are shaping the future of manufacturing. We'll be back next week with another deep dive into a topic you won't want to miss. See you then.